Hello everyone, we are team number 7, and our topic is object recognition. And my name is Yuting, and my team member is Yuxian. And this is our outline. First, we'll give you an introduction to object recognition and our motivation to do this project and our goal to achieve, and our technical parts we will use in this project and the expected results. First, object recognition is an application to recognize objects in the view, and it has two phases. The first one is offline learning phase, and it will accept the input image and it will learn the object labels. And next, we will do online recognizing phase, and it will tell the objects in the incoming images. And why do we need object recognition? Because humans are lazy and we want to do the vision tasks in the real world automatically. And this can improve efficiency and reduce the labor force. So there are some implementations to object recognition. Then, for example, random bin picking is calculate the objects from a random stacking scene, and we use a manipulator to capture the calculated object. And we can also use this into a medical area, like we can help a doctor to do surgeries or to do symptom analysis, like analyze a cardiovascular disease or other cancer. And it can, most importantly, it can also be used in autonomous self-driving car, and for example, like Ducky Town. So this is our motivation to do this project, because we think object recognition is really interesting and it is really useful because it can be implemented in many scenarios. Also, it is really challenging because when the camera goes through different viewpoints and the object may seem really different, like it may be occluded by the other objects, or the shape of the object is really different. And under various light conditions may let the object seem different because, for example, if the object is under dim light and we cannot see the object directly. And also, we cannot see the transparent object directly. However, there are some methods that can see transparent objects, but when it comes to multiple transparent objects, and those algorithms will fail. So this is our goal we want to achieve. And we will build a database for our objects, and we will refer them as our known objects later. So in stage 1, we will capture image in a simple background, and it only includes our known objects. And the algorithm can segment out the known objects from the scene. And in stage 2, we will capture the image in a cluster. And this includes both known and unknown objects, which includes our pre-trained models and the objects we did not train. And we hope that our algorithm can segment the known objects from the cluster. And this is the technical part we will use. For hardware, we will use RealSense SR300 to capture our RGBD images, and for software we will use point cloud library to calculate our point cloud data. And for algorithms, we will segment into 3 parts: object recognition, multi-class segmentation, and occlusion handling. For object recognition, we will train a neural network and or do it by probabilistic model. In multi-class segmentation, we will do this by proposing a probabilistic model, and for occlusion handling, we will train this by convolutional neural network. And there are some difficulties we will encounter during our development of the project. the first one is feature descriptor. Because the environment we captured may contain objects with similar features to known objects. For example, in the upper figure, we can see that the two blue boxes are, the colors of the two boxes are very close. So the algorithms may see them as the same objects, and we cannot know the objects we want. And the second one is close boundaries and reflection. If the two objects are adjacent to each other and their boundaries are really vague, so we cannot separate them accurately. If the camera captures an object that has a high reflection, and we cannot see the object directly, so these two may lead to wrong object segmentation. And for the third one is occlusions. For example, if A object is occluded by B object, the algorithm may see A object as two close boundaries. So we cannot segment the object accurately. And we have come up with some possible solutions to solve these problems. For feature descriptor, we will use joint color spatial representation, which use spatial relationships in point cloud data and color information in RGBD images. And for the occlusion in the middle, we will check if the features in the left and the right side are the same or not. For example, if the feature in the left side of A and right side of A are the same, and we will think that A object is occluded by B object. So this is a demonstrated figure of our expected results. So we will capture a scenario like this. This is a picture from Amazon Picking Challenge. And so we will capture images like this, and there are including known objects and unknown objects. So if we specify that we want the object in the upper left of the shelf, and the segmentation results will show that upper left object in the upper left box. So this is our reference, and thank you.